Welcome to this In Focus webinar on jet blast impact. My name is Ben van Leest. I'm Vice President Aviation of Transoft Solutions, and I'll talk you through the challenges of jet blast. Let's start with the definition of jet blast, or prop wash as it is for propeller aircraft. So according to ICAO, it's the air that comes out of the jet engines or propeller engines, and the impact. Yeah, I've taken definition of FAA is mainly is related to the forces of that jet blast that can be quite heavy and with high wind velocities and temperatures, and that can cause injury to staff present in the airside area, passengers boarding, deboarding, airport equipment, facilities, and also to the pavement or unprotected soil along the edge of pavements. And of course, we have this nice picture to illustrate. Maybe you recognize it from the Top Gear BBC television series when they tested how an older Citroën model would behave under takeoff jet blast of a 747. So let's start with the regulations. I've just summarized in a table the what FAA and ICAO are saying when it comes to the limits of jet blast in terms of wind speed velocities. And EASA is kind of similar to ICAO in that respect. So, and I compare it here in the table with the Beaufort wind strength that all of us know. 0, no wind, basically, and 12 is hurricane strength. Yeah. So on the first lower part of the scale, there is no ICAO limits, but around Beaufort 5, we have FAA that refer to operations on for smaller aircraft, yeah, general aviation or commuter aircraft, with maximum wind speeds of 24 miles per hour, 38 kilometers per hour. And particularly when passengers during bad weather are boarding and deboarding. The next part of the scale from 7 to 12 Beaufort, we have more FAA and ICAO limits that are discussed. The main one is actually 56 kilometers per hour or 35 miles per hour. And FAA is a bit more detailed than ICAO, and kind of divides the situations in terminal tail-to-tail parking, parallel parking around terminals or skewed terminals, hard stands, whereas ICAO, more in as a general definition, talks about the max limit of 56 to be considered as undesirable for personal comfort or for the operation of vehicles or other equipment in the movement area. ICAO has one other reference, and that's on the highest level of Beaufort, the hurricane force, when it comes to buildings. Yeah, and in between there, we have FAA that talk about wind speeds related to breakaway conditions. So we talk about that breakaway a bit later, around Beaufort 8 and 9. If we look at the data that is available, published by manufacturers, it mentions 2 thrust levels of the jet aircraft that are also found in the cockpit. And then we talk about idle thrust. That is the minimum thrust that can be set by the pilot, and that is usually enough to maintain movement when the aircraft is already in motion. And we have the maximum level takeoff thrust, of course, used at takeoff. There is a level in between called breakaway thrust, but that is not a fixed level that the pilot can see in his instruments. That is the level that is necessary to get the aircraft moving from standstill position. And to have a feeling for how much breakaway is in relation to idle or takeoff, not in the airport planning documents of the manufacturers, but more in the operations manual, so that the pilots are using. They talk about something called N1, and N1 is the fan speed of the engine. You see there an engine cross section, and yeah, the fan is at the front of the jet engine that ensures that as much as possible, air is coming into the engine. So if we look at N1 and express idle, breakaway, and takeoff in N1, usually they talk about percentages, and idle is around 25% N1, breakaway between 35 to 40%. And N1 is not the same as the maximum always. That depends on how they calibrate the engines and stuff like that. But takeoff is usually between 95 to 110% of N1. Let's have a look at what kind of jet blast incidents and accidents occur. Of course, I want to start here with the runway. I go from runway to apron, and on the runway, we all know, those videos and pictures from the Caribbean island, St. Martin, where people are really hanging in the fence behind the runway end. Yeah, and with sometimes even fatal consequences. That is one part. Yeah, the jet blast there is obviously takeoff jet blast of the aircraft departing from that runway. On the taxiway, the example I show here is maybe more typical for US circumstances, where you have much more small aircraft mixed with jet aircraft, but those Cessnas or other general aviation airplanes are much more sensitive for jet blast, and when they don't take care and taxi too close behind a large turbojet, then well, you see what can happen. A few other examples. Sometimes when there is a construction ongoing near the taxiway or near parking stands, or where aircraft are maneuvering, then it can be that jet blast, whether expected or not, is coming into that construction area, and usually you have loose objects there. You have maybe large pieces of soil material that can also become projectiles in that heavy wind forces. We can also have on the apron damage to vehicles, and indirectly then also to passengers in those vehicles. An example here is the apron bus transporting passengers to or from the aircraft, where one of the windows was broken by jet blast caused by a 747-8, where freshly trained crew that previously operated on 747-400 thought that they didn't give enough power to initiate the movement. They didn't realize that it can take a little bit longer time before the engines are responding. So they gave a little bit extra, and then it was too much. And broke a window, some people with glass in their faces, so not so nice. On the apron, another example is when people or staff are boarding and deboarding with stairs. The example that I mentioned here is an 747-400 taxiing out from the apron, stopping at the taxiway holding point, and then, of course, using breakaway when starting to move again, blowing, in this case, the pilot from the stairs, and yeah, that's quite a height to make a fall, so you can get severely injured by that. The last two examples on the apron again, and that is a very typical one, that an aircraft arrives and the gate is not yet ready. So aircraft needs to wait on the taxi lane center line, and then when making the last turn, there is jet blast on the opposite gate, yeah, or parking position. In this case, it's even worse when there is one engine operation. Yeah, with one engine operation, the jet blast is even longer, reaching further than with symmetric engine operations. Last example is at the gate, an aircraft that came in. The pilots were a little bit confused and did not follow the exact step-by-step procedure in turning everything off. So they had the beacon, the light, already switched off when the engines were still running, and one of the ramp agents was walking behind the running engines and also got hit by the jet blast. Of course, there are many more. I took some of those examples, and these are all from the last 5 years, actually. When we look at jet blast data, we have the data published by the manufacturers in the ACAP documents. Here I show an example of the very recent 777-9 document that came out earlier this month. And we have those typical jet blast contours from the tail of the engine reaching backwards. The thing is that these contours are calculated nowadays with specific computer models, and they are based on a number of assumptions, such as standard day temperature, that's around 15 degrees, sea level, no wind, usually no pavement slope. You see here that Boeing actually indicates here 1% slope, and that is coming more into the Boeing documents, but yeah, not in all of them, and other manufacturers do not always show 1% slope or another slope percentage. So it's sometimes also difficult, that makes it difficult to compare. Another thing is that those contours are usually based on both engines running. In the 777 document, this latest 777-9 document, it's one of the first ones where I've also seen one engine operation, actually. So yeah, that is the data that we have to work with, and of course, because we have those assumptions, we know that the reality is often different. So if we look at what tools we have available to start analyzing jet blast situations, we have aircraft data viewer, for example, that is static data. You just get an indication, an idea on the length of those contours, how far the jet blast reaches, both visually and in a table. Whereas in AviPLAN, where you can work dynamically with aircraft movements, you can see both the length of the contours and how far the impact goes of the jet blast in the maneuvering while the aircraft